So we're going to take a look here at now how we do regressions. And regressions means that we are taking a bunch of points and we're trying to fit a graph into that. Okay, using DESMOS for that. We're going to do a little bit of that. We talked a little bit about that in linear inequalities, but we're going to do a lot more now in quadratics. And then you're going to be using that next year when you start looking at all sorts of different types of graphs and how do we best fit a bunch of points. Now, to be able to describe what's going on, we may be given like a point, 2 points, 3 points, 10 points, 100 points, whatever the case is. And then we try to kind of use an equation to represent those points and try to figure out how does it best fit? How can we describe past that? How can we take and extrapolate our data and try to find either max or min or try to find a best possible scenario? Or we start to see patterns that are forming and we try to continue those patterns as we go. Now, to do that, it's really, really, really difficult to do that in all cases with pencil and paper, but we're going to take a look at how a graphing software such as DESMOS can do that. And so I brought up the notes here, and I've actually completed these notes and put them on, and we'll come back to it a little bit. But each of those first two that we looked at, vertex form and factored form, they work really well if there's specific information available. If we don't have the vertex, we can't use vertex form. Then we have to use something else. If we don't have the roots, we can't use factored form. We have to use then something else. So they're very specific in how we solve that. Now, DESMOS can create an equation using any 3 or more points of a parabola. Okay, so if we have at least 3 points, so right here we have 3 points, then we can use DESMOS. Now that includes other types of graphs as well. You need at least 3 points. The more, the better. Sometimes if we have more, it won't necessarily fit perfectly. Sometimes it will. But for this class, what we'll do is I'll be giving you 3 points, or I'll be giving you 2, and you can find the third one. And then you're going to be using those to solve the graph. So these are the steps that we need to be done in DESMOS to produce a formula which will help us to describe the situation. Now, DESMOS isn't just going to spit out the formula, it's going to give you values which fit into the formula. I'm going to show you how those exact values work and which values that you're definitely looking for. So, number one, the first thing that we need to do is figure out which 3 points or more we're going to be using for our quadratic. And in this case here, we're going to be creating a table for those points. Okay, so whatever those 3 points are, whether it's the vertex or the zeros or just 3 random points, we're going to be using that to solve for our equation. Now, the second thing we need to do is type in what's called a regression formula. And so I've given you 3 right here. Okay, can't highlight it, that's okay. I need to pull up my tools here. That would be really handy to have. I believe here. No, it's not that. Okay. That's okay. I don't have the tools. That's fine though. These 3 right here are very helpful to use. Okay, we have general form, vertex form, and factored form. You'll notice that there's no numbers in there. All there is A, B, C, A, H, K, and A, Q, R. Ones that we've looked at in the past, which look at specific forms. We type one of these in, or we could all 3 if we really want to, but we only really need 1, and we're going to use general form for the most part. For any regressions, we use general form. We could use vertex and factored, but general form will give us a nice equation right off the bat. So we're going to type that in, and then DESMOS is going to provide us with the values that make up the non-x and y variables in your forms. Okay, and this will be the equation that works for the problem, or the equation that best fits the problem. And when I say best fit, I'll talk about that in a bit of a later video about how we find best fit for a graph. So what we're going to do, we're going to follow these 3 steps to solve these equations. They'll be on the next video. And so, yeah, that will, please follow on to the next video and we'll do a couple of different examples in solving.